All right, let's take a look at another kind of problem that you could potentially see. This one deals with a weak base, morphine. Um, but this one goes ahead and gives us the pH at 9.25 and wants to know what was the original concentration of the morphine. Also calculate the percent ionization. Well, we can go ahead and write out our formula. Okay, I have C17H19NO3. Now, remember, when you have a weak base, you have to include water, okay? The only way that a weak base can form a hydroxide in water is if it takes one of those hydrogen ions from water, okay? So then I'm going to end up with, after the H is removed and added over here, I'm going to end up with OH minus, okay, that was made from my water molecule, and this will get a double arrow too. So I'll end up with OH minus, and then H, because I took the H from water, H, C17H19NO3. So now the initial concentration. Oh, that's a problem. I don't know the initial concentration because I'm only given the pH. But what I can do is I can say, okay, well, I know that my initial concentration of hydroxide is 0. I know that my initial concentration of this is 0. What else do I know? I know that this is going to change by some amount. Now, for acid, we said it was going to change by some amount A. For bases, why don't we say it's going to change by some amount B? Okay, so this is going to go down by some amount, which we don't know yet, B. Okay, now this is a 1 to 1 to 1 ratio. So if this goes down by B, that means this is going to go up by B, and this is also going to go up by B. And so now this is kind of like x minus b. Okay, we don't really know what it is yet. So x minus b, 0 plus b is b, 0 plus b is b. Okay, and so I'm trying to go back and find this initial concentration. Now, I know that I have a Kb value for morphine. If I come down here and look at morphine, my Kb is 1.6 times 10 to the negative 6. We're going to need that, okay? 1.6 times 10 to the negative 6. Okay? So that's my Kb number, okay? So I know that my expression is going to be the Kb equals my products, OH minus, times HC17H19NO3 over my reactant, which is just all I'm going to include is C17H19NO3. Okay, I'm not going to include H2O because it's a pure liquid. So now what I need to do is, before I can find out any of this stuff, I need to figure out what B is. Okay, the only way that I can figure out what B is I know that the hydroxide ion concentration is related to this 9.25. So what I can do first is I can do 14 minus 9.25 equals 4.75. Okay, so that's my POH. So what I can do now is I can do the antilog, or 10 to the negative POH, to find out what my value for B is, to find out what my hydroxide ion concentration is. So my hydroxide ion concentration equals, on second log negative 4.75, enter. So I have an OH value of 1.78 times 10 to the negative fifth power. Okay, so that means that B is this number, 1.78 times 10 to the negative fifth power. So what I can do now is I can go ahead and plug in those values for this, okay? Remember, since this is B and B, this is going to be b squared up here. So I've got my KB value is 1.6 times 10 to the negative 6 equals b squared, or 1.78 times 10 to the negative 5th squared over my unknown concentration of morphine. Okay? And so now all I need to do is solve this math. Let me do that real quick. Okay, now let's remember that this was x minus b, but this value for b is really small, so we're going to say that that's negligible. That's also important to remember. Okay? So I've gone ahead and typed this into my calculator, and I got that this value right here for morphine is 1.98 times 10 to the negative 4th power. Okay, so that is what we do, okay? And all I did was I pretended like that was x, and I just solved for x. All right, so now the percent ionization is going to be the OH minus concentration over the concentration of the original base times 100. Well, my OH minus concentration, I'll do this over here just in case my picture's on the way down there. My OH minus concentration is 1.78 times 10 to the negative 5th divided by my initial concentration of my base, which was 1.98 times 10 to the negative 4th times 100. Okay, so 1.78 second E negative 5 divided by 1.98 second E negative 4 times 100. So this one actually ionizes 8.99%. So that's how you do it, folks. That's the situation. Going backwards is the same deal. You just want to plug in what you can, okay? But instead of solving for B using all this, you've got to use your acid-base rules to solve for B, okay? Once you know what B is, then you can plug that in and do what we do, okay? So we're going to practice this more in class. Come to class prepared to practice, and that's what we got.